So hello guys, welcome back to my YouTube channel. My name is Rajni Singh. Today we are going to explain about analog camera system. So here we will cover about analog systems. This you can see, this is the DVR camera, this one bullet camera and coaxial cable is there, and we will cover so many things in this video. So let's stay tuned here. So we will cover here what are the analog camera component, signal structure, image processing, HDD storage means hard disk, HDD storage calculation, system architecture advantage limitations, and transition to digital IP system. Next slide. Here we will cover what are the analog cameras and their definition, transmission, and role in the CCTV. So camera, actually this is an analog camera. An analog camera capture video as continuous electrical signal rather than digital data. Means they will not capture the video as digital data, they will capture the video as a continuous electrical signal like this. Okay, so that after capturing they will transfer the data through coaxial cable, the same type of cable which we are using in old TV connections. Nowadays TV change, people are using IP camera and Wi-Fi to get video on, but before they people use, nowadays also most of the people are using set-up box like Tata Sky and other brand as well, Airtel. But if you see in that TV connections you will find one coaxial cable. So coaxial cable will look like this. And role in CCTV, so they form foundation like that analog camera found the, they prepared the foundation of traditional closed circuit television. So this is called analog systems, and which were widely used before digital IP camera. What component will cover and required to install a analog camera system? So first of the things will be cameras. So this is cameras, and this is cameras. And why camera required? Camera required to capture the video, and they will capture that video in continuous electrical signal. And to provide a power we also required a power supply unit. So either you can use adapter, 12 volt DC adapter, or you can use a centralized power supply. So coaxial cable is there that carries the signal to recording devices, and DVR required, like DVR required. So DVR takes the analog signal and digitalized it, and it store it. So the DVR will store the data and they will digitalize it, and they will take all analog signal inside that DVR. And also you required one monitor, because where you will view all the videos that camera is capturing, so you have to add one monitor to view all video. And then router also required. Why router required? Because if you want to view remotely and you are outside, so you can use that router to connect that, you can connect that router with this Ethernet port. Okay, and then that DVR will be online and you can use to view remotely using that static IP. Okay, how image will process, like if any camera is capturing video, then how it's process the whole things. So first of the things you can see, this is the camera complete, this is the camera, and this is coaxial cable, here is the monitor, here is the DVR, and this is power supply unit, 12 volt DC adapter. So that just used to give the power to camera. So once power camera will be on, it will start recording, and they will start sending the signal to this DVR. That DVR will receive the analog signal, and then it will digitalize it, and then it will store the data, and it will also view, you can view that all the videos in monitor through the DVR. So you can see this is lens. So lens capture the light. Actually the basic work of lens, it will capture the light, and then image sensor convert light into electrical signal. So that light will convert, this is the image sensor, okay, that will convert that light into electrical signal. And then DSP is there, so this is called DSP. That DSP actually called digital uh, signal processing unit. So this will just process the image and they will make it clear, and then it will convert analog signal, like they will convert into analog signal, and then it will send out to DVR. So what DVR will do? So DVR actually, DVR receive analog signal, like this is the analog signal they will receive from the coaxial cable, and here BNC connector will be there, and it will convert it into digital ADC, like that DVR used to convert the signal from analog to digital, and then it will compress the video. So either they can use like H.264 or H.265. So H.264 if you will use, so suppose if that will use like 5 TB storage, and if you want to go with H.265, so it will reduce the storage capacity up to 50%. So it will just take 2.5 TB storage. So this is the modern technology which like they are using currently. And next one, it store in hard disks. So there will be hard disks in DVR. So all the things, all the data will be stored in the DVR, and it will display it on the monitor. So this is the just image processing uh, things, like how it process. And you can also check this one more picture is there. This is called cam one processing something, main processor. So here is just roadmap how it will work. So there is camera capturing video, analog image capture board, main processor, like this is DSP, and then it will store into the hard disk, and then you can view on the monitor. Okay, this slide is for signal structure. So signal structure, so signal structure will categorized in composite video and synchronization pulses. And one more is limitations. So how their signal are structured. So signal, first part will be composite video. So video signal is carried as a single stream called composite video. It combines two parts, one is luminance, one is, and second one is chrominance. So luminance represent brightness or black and white details, and chrominance carries color information. And synchronization pulses, to keep picture stable, special synchronization pulses are needed, such as horizontal synchronization and vertical synchronization. Horizontal will ensure each line of image start at right time, and vertical will ensure each frame begin correctly. And what is the limitation? So limitations like noise, if electrical interference will be there, so that can image could be distorted due to the electrical interference. And degradation, like quality drop over long cable run, like suppose if you are running long cable, so might be quality of the picture will be down. And copy loss, if you are copying multiple times, it could reduce the quality, unlike digital, like you are using in digital. So in digital it will not degrade the quality, but here it will degrade. And like composite video, you can understand like it's mixing black and white TV with a color layer on top. And what about synchronization? So without these pulses, image would roll or tear on the screen. Like sometimes you see some image are distorted and something. So this is called like if this could happen only with if synchronization pulses are not in good way. So HDD storage, this is the important part of the DVR. Here you can see this is 4 channel DVR. It's 4 channel input is there, and DVR actually digital video recorder. Why we are saying DVR? Because DVR will convert analog signal to digital. Store video footage captured by analog cameras. And amount of storage you need depend on number of cameras, resolution, frame rate, compression format, retention period, and recording mode. So these are the parameters which could affect the hard disk storage. So these factors we have to consider before considering any hard disk for the DVR. So number of cameras, like how many camera you are going to connect with the DVR. Resolution means at what resolution you are going to capture the video, like your camera will capture like it's 180 or like something we have 2 megapixel 3 megapixel something. Frame rate means it's generally it will like 10 fps 15 30 60 something, it's depend upon the your requirement. So frame rate means at what like you are capturing a video means that video is a, just it's not a video, it's a combination of image like multiple. If you will take 15 image 15 pictures in 1 second, it's called it's called 15 frame per second. So that will make a 1 second of video. If you will take uh, 2 second and you capture 30 photos within 2 seconds, so it will create a 2 second of video. So actually video is just a combination of image only. Okay. Compression format, so compression format is we have different type of compression format like H.264, H.265, mpg4, and we have like in nowadays we have so many others like plus is also there, H.265 plus. Retention time means how many days or week you want footage to keep inside the DVR. Recording mode, so in analog it will be continuous recording only, because here no triggered based recording like motion based recording. In IP you can do the motion based recording because that is IP, you can apply analytics and different so many things there, but here you have to record continuous only. So in this segment we'll learn how to calculate the storage. So you can see this is the hard complete hard this DVR, and in this DVR there is one hard disk. So this is storage, and this all is DSP, digital processing unit, that will take analog signal as an input and they will digitalize the signal in digital. So suppose we are going for to calculate hard disk storage, and we have some scenario like we have 4 cameras, and it will record over 1080 pixel resolution, and it 15 fps will be their frame rate. Compression will be H.264, retention time will be 30 days. So first step we have to take, what is the camera resolution. So camera resolution is 1 not h not p. Okay, so 1080p. So we have to check how many pixels will be there inside that mm, resolution. So if you will check, so for this we have 1920 into 1 1080 pixels, because this is vertical one. So dot dot, so like I will tell you how pixels will be drawn. Like this is like one display. So in display it will like dot 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 dot. You are not seeing pictures like smooth and like dot 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 dot. So this is the dots, like how many. Suppose this complete line is have this complete line have 1920 dots pixels, and this complete line have 1080 pixels. Okay, so if you will multiply, you will get total number of pixels here. So approximately it will come 20 lakhs 73,600 pixels per frame. Okay, next is bit per pixel, means bit, how many bit will be there in per pixel. So generally for H.264 will have average 0.1 bits per pixel, means one tenth, and for this it will be 50% more or less, like 0.05 bits per pixel. So total bit, how many will be there in complete frame? So we have to multiply it with 0.1. So I will multiply this pixel per frame with 0.01. So it will come approx this like 2,07,360 bit per frame. So it will come approx 2 MB per frame, 0.2 MB per frame. So now we have to learn how Mbps, like bit per second required. So at 15 Mbps we can say 0.2 Mbps into 15, because this is for one frame. Okay, 0.2 MB, this is in bit 2,07,000. If you will convert into MB, it will come 0.2 MB. So this is for one frame, and if you are going to calculate for 15 frame, it will come 3 Mbps bit rate per second. So this is bit. Okay, it's not, you have to remember there is one bit and one is byte, like this. So next one we have to consider, this is in Mbps, like megabit per second. Now we have to change it into Gbps, like GB, how many GB per camera per day. Like one camera will take how many GB if we are recording for one complete one day, means 24 hours. So 3 Mbps we are dividing it by 8, because we have to change this 1 byte into 8. 8 bit will be in 1 byte, so 1 bit will be 1 by 8, so we have to divide by 8, and this is total second, hours, 24 hours. It will come approx 32.4 GB per day per camera. Now we have to, this is for one camera and for per day. Now we have to consider for 4 camera and 30 days. So what we'll do, we'll just multiply it with 4 into 30. So it will come approx 3.9 TB, means we can say 4 TB of storage required for H.265, means H.264, sorry, it will require H.264 4 TB. If you are going with H.265, so you just require half of the this, because it will reduce 50% storage. Here you can see system architecture, and this is just system architecture of the complete analog system. So this is DVR, this is back of the DVR, and this coaxial cable input. Here you have to connect. So all camera will have two output, one is for power, one will be for coaxial cable. So one cable will go like, and it will connect with the all cameras. This is coaxial cable, it will go and connect with all cameras, same like this. And this is 4 channel DVR, and then this camera also required power, all camera. So we will use one centralized power. So this is 4 channel power supply, and you can see 4 power supply input is there. So you can directly connect uh, with this all power. You can give the power to all cameras. Okay, so here you can see it's connected here, and for this you required outlet, so you can just directly plug it. And then you need monitor. That monitor will connect with this HDMI cable using this port. This is HDMI port. And mouse you can connect with this. Here there is 2 USB port is there, you can connect mouse directly here, mouse. And there is Wi-Fi router, it will connect over the Ethernet port. This, so this is complete setup of DVR. And its architecture for 4 camera 4 channel camera, and DVR is also 4 channel. So 2 TB or 4 TB hard disk, like 2 TB for H.265, and 4 TB for H.264 compression mode required. Like if you are going with 2 H.264, so you need 4 TB. If you are going with H.265, you need 2 TB of storage for this all camera. What is the advantage? So advantage is like simple setup. It will be set up, okay, cost effective, reliable in low bandwidth. So recognition of strength of analog system. So simple setup, no complex networking or IP configuration is required, cost effective, small installation, reliable in low bandwidth. So these are the advantage. Here is we have some limitations. And because of these limitations, that IP and digital camera took over this analog systems. So lower resolutions than IP camera, limited scalability, no advanced analytics, motion detection and AI. So analog camera typically capture video in standard definition HDR, limited HD. Digital details like facial feature or license plate may appear blurred. Modern IP camera offer full HD, 4K and even higher clarity. Limited scalability. So each DVR support a fixed number of channel like 4, 8 and 16. Adding more camera required new DVR unit and cabling. IP system in contrast expand easily through the network switches. No advanced analytic, motion detection AI. Analog system record continuous without smart triggers. They lack feature like motion based alert, facial recognition or object tracking. IP system integrate AI for smart surveillance and automation. So transition to digital IP. Compared to DVR based analog system with modern IP and VR setups, sharper video, remote access, smart features, scalability and future ready. So IP support HD, 4K, analog is limited. IP allow viewing anywhere via app or cloud. Analytics, AI alert, facial object recognition, add to easy to add cameras on network, software update, integration with smart systems. So these are things, that's why we just move from analog to IP. So thank you so much guys to watch my videos. I hope you have learned it, you get some new ideas. Please like, comment, share and subscribe, and stay tuned for more insights on smart building systems. Don't forget to subscribe my channel. Thank you so much. We'll see you in next video.